So what you have in front of you is your assessment of your knowledge and application or ability to apply Newton's second law. Now, you're going to want to write a few things down probably on that sheet that I just gave you, okay, because I'm going to go through a few kind of tips, hints, explanations, clarifications of some of the questions, okay, so that you can get the maximum number of marks possible, okay, on this assignment. So make sure that you're paying attention. Make sure you look at the point value for each question. Like question number 1 is out of 2 marks. There's really not much to it. But if you forget things like significant digits or vectors, you very quickly lose the very few marks that could be available on a question like question number 1. All right. So I guess my point is don't overthink it. And remember the important stuff like significant digits and vectors. Okay, question number 2, not really any tricks to that. Okay, you've got just a Newton's second law question. It does give you some velocities. Make sure you realize that these are velocities and not accelerations. This is a time, okay, and that you use them correctly. Number 3 is saying you've got a single force vector, 720 newtons, 38 degrees north of east. Determine the magnitude of the force north and east. You are simply finding the vector components here, finding x and y. That's it, okay? Don't overthink that one. You guys know how to find vector components. Question number 4 gives people trouble all the time, and I still don't get why. On number 4, there are 3 parts, okay? So there's this is part A, okay? This is part B, and this is part C. Okay. You are being asked to calculate the acceleration of that box. It's the same box in all 3 parts. Okay, it's a 5 kilogram box. You're being asked to calculate the acceleration in part A when there's a 60 Newton force going this way and a 40 Newton force going this way. All right, and it's saying relative to the x-axis. All right, we are wanting our directions to be relative to the x-axis. So this many degrees above or below the x-axis. Okay. In part B, I've got an angled force. It's still 60 newtons, but now it's angled. Okay, that angle is listed there. It's 45 degrees. It's hard to see it, but it's right here. Right. So that angle there is 45 degrees. Right? And then we still have the 40 Newton force going along the x-axis. And then in part C, they're both pointed along the x-axis. So essentially, what I've done there is given you the free body diagram for A, B, and C. So you don't need to draw it. It's already done for you. But that's not going to get you what you need. You probably need to draw a different kind of diagram for 2 of them, okay, in order for you to get what you need in order to get the acceleration. All right, so these diagrams are your free body diagrams. Okay, don't treat them like they're something else. All right, number 5 is telling you that you have a 36.5 kilogram sphere and there's 2 forces acting on it. One of those forces is 113 newtons and it's directed along the positive x-axis, so it's horizontal. Okay, and then there's a second unknown force. Okay, what's the magnitude and direction of that force if the sphere is accelerating at 3.96 meters per second squared, 21 degrees above the x-axis? Okay, so it's giving you its overall acceleration and you know its mass. There's something you can find with those 2 numbers that might help you to find the missing force. All right, so it's kind of a vector question, but it's kind of a backwards vector question. Okay. Okay, for question number 6, that's our spacecraft. It's not very pretty. It has 4 engines and can only fire 1 engine at a time. The engines are either on or off. There's no throttle. If they're on, they exert 68,000 newtons worth of force. Okay, we have to do this because if there's a throttle, the question becomes very complex. If you can fire more than one at a time, or there's a throttle, the question becomes very complex. We're simplifying it by saying fire one engine at a time, and they're on or off. When they're on, they exert 68,000 newtons of force. Okay, so we know the mass of the ship. Okay, we know how much force an engine can exert, and we know that initially the ship is going this way at 2,170 meters per second. What you have to calculate is which engines need to be fired and for how long in order to no longer be doing this, but be going this way at twice that speed. Okay, so essentially there's two parts. Okay, you need to stop, and then you need to get going the other way. Okay, that's about as much as I'm going to tell you. All right, we're not rotating the ship. Okay, the ship is not going to turn; it's just going to stop and then go that way. That's why there's an engine on each side. Okay. Question number 7. Okay, we've done a bunch of questions like this. They're static questions. Okay, got a street lamp. It weighs 150 newtons. Okay, it's supported equally by two wires that have an angle of 120 degrees between them. Okay, what's the tension in each wire for part A? And then in part B, we're saying we reduce the angle from 120 to 90. Now what's the tension in each wire? Okay, really watch this in that question. All right, number 8, another static question. We've done like 3 or 4 like that one as well. Okay, it's a sign supported by two wires, right? One is angled, and the angle is given to us as 30 degrees. So this angle here is 30 degrees. B is horizontal, right? We're trying to calculate the tension in cable B, in the horizontal cable. All right, number 9. Number 9 is a suitcase being pulled along a level floor. This number 9 is not an inclined plane question. That's the most common mistake with number 9 is people see the angle and they see this as an inclined plane. This is me with a suitcase that I'm pulling at an angle, but the suitcase is moving along the floor horizontally. Everybody with me there? I might be pulling at an angle in this question. I am, or Mia is, okay? But the suitcase is not moving at an angle. The suitcase is moving along the floor. We did 2 questions like this one when we were talking about friction and the vector nature of forces. All right, so we've done ones like this. Make sure you keep in mind the vector nature of forces, and especially that the suitcase is moving horizontal. Similar, but we did some other ones that are more exactly like this question. Okay. All right, for question number 10, okay, we got a box that weighs 215 newtons. It's on an inclined plane, so 10 and 11 are both inclined plane questions. Okay, you guys know how to do inclined planes. Those ones shouldn't give you too much trouble. Okay, just do your usual inclined plane thing. Just be mindful of what I'm giving you in those questions. The box is weighing 215 newtons. Okay. All right, questions on any of those? Okay. I haven't decided, but I will. I'll let you know in a few minutes. Okay. All right, you got the rest of class to work on this. I would think you could get a lot of it done if you were focused. Okay. Okay, due date for that's going to be this Friday. Still doing a live tomorrow. That'll be next week. Yeah. That one, the procedure is so short on the lab we're doing tomorrow that like you'll get most of the lab report done in class tomorrow. It's quick.